All right, so I'm basically going to prove with the slope formula what you just saw on the graph slide. So remember, our slope formula is m equals y2 minus y1 all over x2 minus x1. All right, so I'm actually going to start with the right table first because that is a linear function. And I'm going to look at the slope between these 2 points first. Okay, so what I'm actually going to have, looks a little weird because we have negatives, but that's okay. I'm going to have negative 5 minus negative 8. Those are my y values, all over 0 minus negative 1. All right, and when I do the math, what that is going to give me is negative 5 really plus 8, so that's going to be a 3 over 0 minus a negative 1 is actually 1. So that's going to give me a slope of 3 over 1. All right, now I'm going to compare that to the slope at the bottom of the table. All right, so again, I'm still using my slope formula. I'm going to do 7 minus 4, those are my y values, over 4 minus 3. All right, well, 7 minus 4 is 3, 4 minus 3 is 1, boom, boom, same slope, or we could say constant rate of change equals, so this has to be the linear function, okay? On the flip side, I should have gotten a different color, but I'll do this in red. I'm not going to deal with fractions because blah. So let's look at the slope between these points here. So I would do 3 minus 1, those are my y values, over 1 minus 0, and that is going to give me 2 over 1. All right, so the slope at the kind of top of this table is 2 over 1. Let's compare it to the slope at the bottom of the table. So I have 81 minus 27 all over 4 minus 3. All right, let me just, 81 minus 27 is going to give me 54 over 1. Dang. All right, so look at this. We started at 2, not very steep, and we end at 54. That's very, very steep. All right, so this is not, right, a constant rate of change, obviously, right? It changed from 2 to 4, so this must be exponential. So again, if the slope is staying the same throughout the table, that means we have a constant rate of change, which is going to make a straight line, which is linear. If the slope changes throughout the table, like we have here when it went from 2 all the way to 54, what that means is it was less steep. It ended up very steep. That is not a constant rate of change. It's going to create a curve, which gives us the exponential function.